lesson describes the nature, hazards and effects of wind shear. And by the end of it, you will be able to understand these effects, particularly concerning aircraft energy gain and loss, and be aware of the conditions under which the phenomenon of microburst can occur. Wind shear is defined as a sudden localized change in wind speed and/or direction that can occur vertically, horizontally, or both, and at any altitude. It can subject an aircraft to sudden updrafts, downdrafts, or extreme horizontal wind components, causing sudden loss of lift or violent changes in altitude or vertical speed. Wind shear can cause abrupt displacement from the flight path and may require substantial control action to counteract it. Wind shear encounters can be very dynamic events, which strike suddenly and sometimes with devastating effect, beyond even the powers of experienced pilots flying modern and powerful aircraft. An encounter may cause alarm, a damaged undercarriage, or, at worst, a total catastrophe. The first and most vital defense against wind shear is avoidance. The most powerful examples of wind shear are associated with thunderstorms, that is, cumulonimbus clouds, or cumins as they are often called. However, wind shear can also be experienced in association with other meteorological features, such as the passage of a front, a marked temperature inversion, or even turbulence caused by topographical features. Microbursts are associated with thunderstorms, and are one of the most, if not the most, dangerous source of wind shear. They are small-scale but intense downdrafts, which, on reaching the surface, spread outwards in all directions from the downdraft center. This causes both vertical and horizontal wind shear that can be extremely hazardous to all types and sizes of aircraft, especially when within 1,000 feet of the ground. A microburst is typically less than a mile in diameter as it transcends from the cloud base to between about 1,000 to 3,000 feet above the ground. In the transition zone near the ground, the downdraft changes to a horizontal outflow that can extend to around 4 kilometers, just over 2 nautical miles, in diameter. To give you an idea of the power of a microburst, downdrafts can be as strong as 6,000 feet per minute, which is beyond the rate of climb of a lot of aircraft, particularly in an approach configuration. And the horizontal winds near the surface can be as strong as 45 knots, resulting in a 90-knot shear as the wind changes to or from a headwind across the microburst. These strong horizontal winds occur within a few hundred feet of the ground, where aircraft on approach and climb out are vulnerable at low speeds. An individual microburst seldom lasts longer than 15 minutes from the time it strikes the ground until dissipation. A microburst intensifies for about 5 minutes after it first strikes the ground, with maximum intensity winds lasting around 2 to 4 minutes. These are maximum values, but they do indicate how it is possible for even large and powerful aircraft to become uncontrollable if they encounter such extreme conditions. Microbursts may be concentrated into a line structure, and under these conditions, activity may continue for as long as an hour. Once microburst activity starts, multiple occurrences are not uncommon and should be anticipated. Here, you can see a typical normal takeoff profile with a steady climb out. By comparison, if an aircraft takes off into a microburst, it will first experience a headwind, which increases performance without any change in attitude or power. This is followed rapidly by a decreasing headwind and performance, and a strong downdraft. Performance continues to deteriorate as the wind shears to a tailwind in the downdraft. The most severe downdraft will be encountered beneath the centre of the microburst and for a short distance past it, and may result in an uncontrollable descent and impact with the ground. When on the approach, power settings and rates of descent required to hold the glide slope should be closely monitored. If wind shear is encountered, it may be difficult to stay on the descent path at normal power and descent rates. If there is ever any doubt about your ability to regain a normal rate of descent on a stabilized approach to land without abnormal maneuvers, then you should apply full power and carry out a missed approach procedure or go-around as appropriate. Wind shear can vary enormously in its impact and effect. Some instances, such as microbursts, will be more severe and consequently more dangerous than others. When countering the effects of wind shear, it is safest to assume the worst case, as it is impossible to tell from the initial indications how severe any wind shear will be. On the whole, prevention is better than cure. But if you are caught unexpectedly by wind shear, use maximum effort to recover, only moderating the recovery when safe. The table now on the screen will give you an idea of the indications you may get and the associated recovery actions needed during a stabilized approach. But it is as well to appreciate that approaches should not be attempted into known wind shear conditions. The relationship of an aircraft in a moving air mass to its two reference points, the air mass itself and the ground, must be fully understood. On passing through a shear line, the point at which a rapid change of wind vector occurs, the change in airspeed will be sudden, but the inertia of the aircraft will initially keep it at its original ground speed. The wind is, of course, a form of energy, and when it shears, an equivalent amount of energy is gained or lost. A rapid increase in headwind or a loss of tailwind are both energy gains, and will temporarily improve performance. Downdrafts are a significant danger at low level as they cause an energy loss, resulting in an increase in rate of descent. A very similar effect will occur with a sudden drop in headwind or increase in tailwind, again with significant energy loss. When considering recovery actions from a microburst, the sequence of increasing headwind, followed by downdraft, followed by increasing tailwind, is the worst-case scenario that might be encountered on the approach or after takeoff. The presence or likelihood of thunderstorms will be known from forecasts or weather reports, so the increase in speed from a rising headwind should be seen as the forerunner of a microburst or downburst, a more general term for this kind of phenomenon. Even at this early stage, any hope of flying a stabilized approach should be abandoned, and a go-around carried out as the only safe course of action. The initial rise in airspeed and rise or balloon above the glide path should be taken as a bonus, and the energy gain capitalized on by setting go-around power and attitude, typically 15 degrees, immediately, and holding it through any turbulence or buffeting. The next phase may well see these initial advantages being rapidly eroded. The downdraft now strikes, airspeed may be lost, and the aircraft may actually descend despite the high power and climb attitude. It will be impossible to gauge the actual angle of attack, so there is a chance of stick shaker activation if one is fitted. Only then, or at any stall symptoms, should the angle of attack be reduced to avoid the stall. The point at which the downdraft starts to change to an increasing tailwind may well be the most critical. The rate of descent may lessen, but the airspeed may still continue to fall, and the height loss may have breached the obstacle clearance safety margins. It may be necessary, given that maximum thrust is already applied, to go to an attitude that activates the stick shaker and hold it until the aircraft passes clear of the microburst. When the wind shear risk is longer term, because of multiple or slow-moving thunderstorms, it may be possible to take off from a longer runway or one that points away from the risk area. Another precaution against wind shear is a higher rotate speed, with due caution over tyre limiting speed. Any extra speed or climb rate would be an advantage in a microburst encounter. At a low height, however, there is little safety margin, and the ride would be at best uncomfortable. If extra power is available, it should be used without hesitation, ignoring noise abatement procedures and maintaining a high pitch attitude just below stall warning angle of attack. In summary, the vital actions to be carried out in the event of wind shear, on takeoff or on the approach, are as follows. Use the maximum available power as soon as possible. Adopt a pitch angle of about 15 degrees and try to hold the attitude, and do not chase the airspeed. Be guided by stick shaker or other stall warning indications when holding or increasing pitch attitude, and be prepared to reselect a slightly lower attitude. Ground-based wind shear detection equipment has been in use in the USA since the 1970s, in the form of the Low-Level Wind Shear Alert System, which relies on a series of anemometers located around the airfield and providing information to a computer which analyzes the data and provides a warning to air traffic control if hazardous wind shear is detected. This system is gradually being replaced by terminal Doppler weather radar. These ground-based systems have their limitations, and often the most useful indications of wind shear are gained from aircrew reports. Some aircraft have a predictive wind shear system as an integral part of their weather radar. But regardless of how the wind shear is detected, it should be reported to air traffic control as soon as possible, including details of location and altitude, and gains and losses in height or speed. If the wind shear was such that a flight safety hazard existed, then an appropriate flight safety occurrence report should be completed after flight. Awareness of the conditions from timely reports will enable other aircrew to plan and brief accordingly. Thunderstorms will usually feature when appropriate in aerodrome forecasts, providing a forewarning, and, unless embedded in other cloud cover, will usually be visible both by day and night, giving pilots a mental jog to think wind shear. Once alerted, there are several visual indications to look for. These include divergent smoke plumes or windsocks, dense shafts of rain or hail, and virga, which is precipitation which may fall from a cunim but evaporate before reaching the ground. Divergent wind patterns can also be detected by the movement of long grass, crops and trees, and disturbances on the surface of sea and lakes. Rising dust or sand will also reveal strong or gusty winds. To observe and recognize any of these clues will suggest that the wind shear danger is very close, if not imminent. Nevertheless, a few seconds of warning may make all the difference if the warning is heeded and acted upon promptly. Most pilots will experience wind shear in one form or another at some time during their flying careers. For most, it may be no more than a swing on takeoff or landing, requiring a momentary use of a large rudder deflection, maybe put down to a gust. A few will experience more extreme, dare we say, full-blown instances of wind shear, which will stretch their skills to the limit. A very small number will find their skills and reactions inadequate. There is no sure way of knowing the severity of any wind shear that may be encountered, so it is better not to put one's skills to the test rather than find them inadequate. Wind shear, particularly when linked with thunderstorms, has caused disaster in the past and may well cause it again, but will not harm those who understand its power and have the good sense to avoid it. An inadvertent encounter on the approach is most likely to destabilize it to such an extent that a missed approach is the only safe course of action, and the sooner that decision is made, the safer it is likely to be. Other encounters must be treated according to the conditions, but any hint of energy loss must be met with a firm, prompt and positive response in line with the guidance given. Finally, remember that the best defense, in this case, is avoidance. But you cannot assume you will avoid wind shear, so be prepared for the actions you may need to take.